Welcome to vsdevelopers.io. In this video, we will be looking into encapsulation as part of our object-oriented analysis and design. In the last video, we have seen abstraction. We have understood that the complex implementations can be abstracted and used with one simple name, be it primitive data types, be it derived data types, or even function calls or class declarations. All these are abstractions. Now, how is this abstraction possible? When you ask that question to yourself, you would find out that it is possible with encapsulation. So with encapsulation, what we are doing is we are keeping the things hidden and we are exposing only those parts that are required to be exposed to the outside of the world. Okay, let me explain you a little bit more. So you started developing a library. That library has some of the encrypted algorithms. And these encryption algorithms are sensitive. You do not want to expose how you performed that particular encryption for very apparent reasons, right? So how do you hide the implementation part yet only expose the function declaration or the class declaration to the programmers? So that when a programmer uses your third-party library, he only knows how to use it, but he doesn't know how it has been implemented. All this is possible because of encapsulation. Now you can restrict what to expose, what not to expose. In a header file, you can declare a class and the function. The function name and its parameters, return type, can describe what the function is going to do. When it comes to class name cannot reveal so much. Therefore, in a header file, you declare the class, you declare the data members, and you declare the member functions. So data members are what you have, right? Your assets. And then the member functions are what you do with those assets, with those data members. Now, when they are declared inside a class, they are typically accessible to anybody and everybody. Now, how you restrict them, how you give your access specifiers very restricted to particular data members and member functions, which you do not want to expose. Let us dive into the code and try to understand one by one, step by step. By the end of this video, you should understand the concept of encapsulation like never before. Let us begin with a simple example. You have two classes here, class A and class B. This is declared in an encapsulation intro.h, an header file, which you typically distribute it outside. So when you want somebody to use your library, you would distribute this header file. In this header file, what you have is two classes. By thinking that the programmers who consume your library would instantiate these classes and make use of the functions so that they are aware what functions are inside and what data members are there so that they can call them and use at their convenience. Now, in this class A, you only exposed what is get and what is set. So they understand with the help of documentation or comments, they understand, okay, this is to get the variables that they are declared in private. So another function set will set the values that you send it via another function that you implement on top of it. So here, if you see, this get is returning value and the set is not returning value. So this gives them the information, the return type and the parameters. So both of these functions are not taking any parameters. Now, so as class B, they're both the same, more or less, just that the class B is different from class A with its name so that you can create two distinct objects. Now, even if you instantiate an object of class A, you cannot directly access this I, J, and K. So these I, J, K variables can only be accessed or updated using get and set, these public member functions. Public member functions are accessible via object from outside of this class, but not the private. So this is where you are hiding the information, what you want to hide, and you are exposing what you want the programmers to make use of it. For the class A, right? For the class A, what you have is a member function, in fact, two member functions. So what you write on top is the class name followed by your data members, that is your int I, j, k, then your get and set functions. So int get and int set. This is how you represent a class diagram for this. And yes, there will be a double line here to distinguish from class name to data members. So as your class B, you would write it in the same way, right? So class B, begin with the name, and then you have your data members and your member functions. These two classes are represented using this UML diagram. This can be included in your documentation as well, so that it is easy for the programmers just to look at the UML diagram and understand what do you have inside your library. I have given out the header file and UML diagrams out to the world. Now, how do you implement it so that your details are hidden? Look at this. You have the get from class A. So you have implemented it in your .cpp file, which is hidden from the outside. Nobody knows the source code of this .cpp because you have given out either dynamic library or static library. So you have implemented get, which returns the sum of those three data members you have. And the set function, similarly, I, j, k are assigned to 0. This is for a demo example. And likewise for your B class, you have implemented this get and then set is assigned to -1. Now, that is the implementation part, right? So you can write the different logic, different your business logic as per your project, your needs. You implement it. Nobody knows what the IP algorithms that you have used. That is, if you have used any patented algorithm that you do not want anybody to see it, it is hidden from the outside of the world, and it is accessible to only those accessible, not the source code. You can refer to it. You can make use of the method if it is public inside your class, right? Now, let us see how as an application, right? So I bought your library, which you have used, declared with the given example like A and B, and you have distributed it to me with the header file and UML diagrams. Now, by looking at the diagram, I can understand there is a class called A, class called B. I have declared two objects, A of A, B of B. I know from the UML diagram or the header file that there is a set function. So I want to call set and I want to see what is the output of it. So then I call a.get. Likewise, b.set, b.get. Now when I run this, what happens? Yeah, a.get gives you 0, which is because it is assigned to 0. When you even sum them up, I plus j plus k, it becomes 0 and returns you that. Whereas b object has -1. So -1 added 3 times, it becomes -3. So you get the output as -3. This is how I make use if I'm using your third library that you have developed and distributed. You see how the details are hidden to the outside world. I do not know how you have implemented, what is your secret code, secret logic, or one of the encryption algorithms that I don't want anybody to know, right? So this is where the encapsulation is heavily used in object-oriented programming. Let us look at the complex example. We have a header file, which is class stack, and then it has some data members and public methods. So if you have to draw a class diagram for this, how would you draw? So the top one, as you know, it's a class name called stack, and then it has data members. Okay, so this data member itself is a struct. Okay, so struct link is one data member, and this is the only one it has in the private section. And then data members, that is member functions, are 5. So you have init, right? And you have push, peek, pop, and cleanup. Well, if you take a look at this, what you wanted to do here, why did you declare the link inside a stack? Right? So you do not want the consumer of your library to know what is link, how the link is maintained, what you want them to access. So it's a stack, right? So stack, what it can do, you can initialize the stack, you can push elements into the stack, you can then pop them, right? Or you can just see what is the top element by peek, and then you can clean it up. These are the operations you want the consumer to know. Therefore, only these 5 methods are available outside for the people who wants to consume. Now, how the data is maintained, how the link is built, how the stack is formed, no, you don't want them to know. Therefore, you have declared the class in this way. Now, if you decode this and go deep into struct, so if you draw a diagram for struct, so this would be your link structure, which is again, this is the form of a class, which has, right, data members. That is, all of them are in fact in the public section. So, in struct, the default, if you don't mention, everything is public. And now you have data and you have next. And you have another member function, which is initialize. See, this initialize is different from this initialize, right? So this is now represented this way. So you have the stack class making use of link structure. Well, let us go ahead and see how you implement this class, which is hidden from the outside of the world. And then later we'll see how do you consume it. The screen, what you see is your implementation, right? So you have stack, and inside that you have link, well, which is stack, and you are referring to link inside the stack, and then you are implementing the initialize, right? So this method, what you have done here, you have initialized the data members of link, data and next. So data to that you receive, and next to nxt that you receive as part of the arguments. The next one is void stack initialize. You see the difference. This method, the second one, void stack initialize, belongs to this. Well, it belongs to the stack. The stack initialize belongs to implementation of this. Whereas if you see this initialize, right, the stack link initialize is the implementation of this. You get it? So this is inside the structure, this is inside the class. Now you have initialized it, and now let's see what you have here. The stack as push, peek, pop, and cleanup. So you go ahead and implement them. Stack, push. So when you push, you will receive an element what to be pushed inside the stack. So you are implementing it. Now you see, you don't want the consumer of your library to know what it is inside. So link, pointer, new link, and then you are creating a new link. So with this, what you are doing is you are first creating a link. That is, if you assume the memory layout for the link is this, so what you have inside your class, right? So in the link structure is data and next. So if you think this is your data, right? So if you take this as your data and this as your next, this memory is allocated for you, and you refer to that with a pointer. So if you go back to the implementation and see what you have, so new link, for this pointer, you are referring to it as new link. This new link is creating a memory layout like this for you. And then you are calling the initialize method that is inside your struct. So when you initialize it, what happens? Whatever you are sending will be initialized to these memory space. And then you are also marking head as your pointer to the structure that you have just created. So with that, what happens is you are pushing one link into the stack. Then peak should give you whatever is on the top, right? So if the stack is empty, you return. If the stack is not empty, you just get the head of data, right? So head of data is this is your head, and head of data is this. So whatever is top, you will get it. If you call push multiple times, what happens? So many such variables will be pushed into the stack, one above the other. Every time you push, your next one becomes, the new one becomes the head. The new one becomes the head. Well, so whenever you pop, the first one to come out is this. And whenever you push, it will always go and sit on top only. That is what the pop operation we are doing here. And then cleanup is empty here. Uh, all right, so this is your part of implementation of how do someone consume your library. Let's say now I want to read the text inside this simple.txt file, right? So I want to push all the text from this file line by line into the stack and then pop it out using the library that you have just built, the stack library that you have just built. So I have a simple.txt file here, and then I have stack of strings. So this is my own class as a consumer. Now I have developed my own class. Let us take a look at that. That is going to be interesting to learn how encapsulation is going to be useful to you. Stack of strings. This has a member of your stack class that you have exposed. See, I have included the header file, right? Stack.h, what you have given me, right? And therefore, I can access and I can include your stack object class into my class. Now, stack of stack, all right? So this is not inheritance, guys. This is object composition. Okay, so what you want to do is you're not inheriting the properties of the stack class that you have given in your library. Rather, I am embedding that into my class as a private member. Okay, so now I have my own push, my own peek, my own pop. Now these three methods will internally use stack, what you have given me, so that I have the luxury of passing whatever I want to pass. Because in your stack example, you have void star, right? So that means you are giving a provision to generic data type. So that you can use this stack for integers, you can use this stack for strings, right? So now I've decided to use this for strings. Therefore, void push, and then I would use stack.push. This is your library that you have built. Now, peak will return just the peak element, that is whatever is in the head. Pop will pop the element so that that element is removed, the top element is removed. This is how you built it. So if you draw again a class diagram for your class, this is your let's say, let's call it my class. Now I'm making use of the stack class that you have given me, the stack library that you have given me. Now I want to use this for stack of strings, right? So therefore I name my class as stack of strings. Well, now when I declare this stack of strings as my class, then what am I doing? I'm declaring one private member, which is the class that you have given me, which is stack. All right. Now followed by the new methods of my own type, which deal with strings. So likewise, you can have stack of integers, stack of real numbers. You can have different classes that deal with different data types. Well, that is the reason you have void star in the previous example. That is the library that you have written. Now, how would I make use of it? I have a file. So I have declared an object of text lines of stack of strings. Then I'm getting one line every time from the simple.txt and then pushing it to the stack. Well, so I'm not calling your stack.push, but I'm calling the stack of strings which deals with strings and pushing it. Next, I'm popping from the stack until the end of the file, right? And is not equal to 0. That is, sorry, it is not until end of the file, until the stack is empty. So while popping, I'm not dealing with the file. While popping, I'm only dealing with the stack that I've created, text lines. So text lines dot pop, if it is not equal to 0, I'll continue and I'll print whatever I have popped from the stack, and then I'll continue to do so until the stack is empty. Let us run and see. Before we run that, I want to show how the stack is built up now. So if I have, so this is stack, and I have, let's say, string 1, right? So this will be pushed first with the line number that you have it, 64 and 65. I fetch the line and I push it. Then I have string 2, right? That will be pushed. And string 3, that will be pushed. Let's say I have only 3 strings. Then next, I'm popping from the stack. So when I pop, what will be printed first? String 3. So the output should be string 3 followed by string 2 followed by string 1. This should be the outcome. Let me run and see what is going to come out. It's building. It's okay. It is built. Now let me make it a full screen. Well, so the file simple.txt, it has string 1, 2, 3, 4, 5 as its content. Now, therefore, the stack includes string 1 first, pushes string 2 next, 3, 4, and 5. And when you pop, right, it pops in the reverse order. It will be printed string 5 at the last, whatever you have pushed first. So let me open the file and show you what is inside the simple.txt. Well, you see here string 1, string 2, string 3, 4, and 5. So I read 1 first, push it down to the stack. String 2 next, push it on top of the string 1. So therefore, you see string 1 at the end to be printed. String 5 will be printed first. So this is how you will make use of encapsulation. Without encapsulation, there is no security. There is no privacy part of your classes and objects. If you want to restrict your implementation, if you do not want to expose your internal details, encapsulation is the way. Without encapsulation, there is no object orientation analysis and design. Hope you have understood the part of encapsulation with examples, UML diagrams, and theory part of it. If you like it, do comment. If you don't like it, do comment that you did not like it. So I'll try to simplify it and I'll try to create better videos for you. Thank you for watching, and please subscribe to VS Developers YouTube channel.